So previously we learned that whenever we got redundant paths, you see between B and C, we got redundant paths. It is recommended to use loopback interface as a neighbor instead of the physical interface. Why? If I use physical interface in router B, instead of saying 3333 as a neighbor, if I'll give 10.1.1.2, what will happen if this link goes down? I lose the neighbor. But because you got loopback, you will have neighbor via this link. If this link fails, no problem. There is another link to take you to 33333. So the neighborship will not go down even if you have just one link up. That is enough. Forming neighbor using loopback is the best option. Most of the time in IBGP scenario, you will form neighbor with loopback. See, that was even mentioned somewhere here. Here you see this point. The neighbor update source command is normally used only with IBGP neighbors. The reason is only in the IBGP scenario you will have redundant paths. EBGP, very rare to see redundant paths. See, you got only one link here, only one link here. EBGP you will have single connection. But in IBGP, it is inside your organization. You will have redundant paths like this, or you may have paths like this, redundant paths like this. Between these two routers there are redundant paths, and so on. So this is mostly seen in IBGP scenario. So whenever you do that, you need to make sure you source it from your loopback interface. Why? Because if match is not found, the packet will be ignored. The source address will be compared with the neighbor statement. The source address of the incoming packet will be compared with the neighbor statement. So here, when you don't use this command update source loopback 0, one of the exit interface address will be the source which is not matching with the neighbor. When I say update source loopback 0, router B will start using loopback 0's address as the source address. Now when the packet goes to C, C looks into the source address which is loopback 0 of B 2222, which is also matching in the neighbor statement. Yep, that's important. The source address of the incoming BGP packet should match with the neighbor list. Kindly mute someone who is not muted. Thank you. So, in order to match with the neighbor statement, I have to source it from the interface which has got the IP address that is mentioned in the neighbor table. That is the reason why I use update source command. Now, in some rare situation, I may have a redundant link between EBGP. See, this is different autonomous system. There are different autonomous systems. Now, we have redundant paths even between EBGP. I said it's a very rare situation. In EBGP, if you simply say update source loopback 0, that's not enough. In IBGP, we said update source loopback 0 whenever you form neighbor using loopback address. But in eBGP you need to do something more. That is what this slide explains. Anyway, let's go one more time. See, IBGP. In IBGP we just said neighbor 3333 and then update source loopback 0. That's all we did in order to form neighbor using loopback between IBGPs. But between eBGP you need additional configuration, one more extra line called eBGP multi-hop. Why we need this eBGP multi-hop? You remember long back we learned a rule. For eBGP, neighbors need to be directly connected. For eBGP, neighbors need to be directly connected. eBGP. For eBGP, neighbors need to be directly connected. For IBGP, not necessary. But for eBGP, it needs to be neighbor needs to be directly connected. You know why? This is the reason. Let's say here you got IP address 10.1.1.1. Here you got IP address 10.1.1.2. And loopback here is 1.1.1.1. 2.2.2. Now, when I go to router 1, focus on the class. When I go to router 1 and say neighbor 10.1.1.2, what this router will do, what this BGP will do, BGP will check the routing table and it expects this one 10.1.1 network to be a directly connected network. In the routing table it should say directly connected. The word should be there. Wait, let me do and show you parallelly, only then you will understand this better. So we got these two routers between which we are going to form eBGP. Let me quickly configure the interface with the IP address. The interface name is F00. Next is we are going to, before that let me go and finish second router. Done. So we got the basic IP address configuration. I'm saying router BGP. Okay, let's say the autonomous system number of this is 20. And this one will be 10. So going back to router B, and I say router BGP 20. Neighbor, listen, when I say 10.1.1.1 remote AS 10, router 2 knows that this is an eBGP neighbor and this network should be directly connected. How it will check? It will check the routing table. Show IP route. Yes, it is directly connected. See, it says directly connected. It is said directly connected. Only if this is true, BGP will send the TCP three-way handshake and try to form BGP neighbor. If it is different, if it says connected via this, that, if you have a static route, something like that, it will not even send the packet out. It needs to be what? Directly connected. The reason is the outgoing TTL is set as 1. If any packet needs to be sent with a TTL of 1, focus on the class. If any packet needs to be sent with a TTL of 1, that destination should be directly connected. Only then it is possible to send a packet with a TTL of 1. Now going back to the presentation, look at this. The default TTL value for eBGP is 1. Directly connected, no? TTL will be 1. eBGP by default, the outgoing TTL will be only 1. But for IBGP, the outgoing TTL will be 255. For IBGP, there is no restriction like directly connected. There is no limitation. There is no constraint to be directly connected. But for eBGP, constraint is it needs to be directly connected. When it is seen as directly connected network in the routing table, then the packet will go out with a TTL of 1. So we have said neighbor 10.1.1.2 here. So what this router will do, it will generate a packet with a TTL of time to leave 1. Only if this is seen in the routing table as directly connected. So now it generates a packet with the source address of the exit interface address 10.1.1.1, destination address is 10.1.1.2, and it will send the packet out, and as soon as it goes here, it becomes TTL what? 0. When this packet goes to the first hop, the decrementation will happen. TTL, time to leave, will always decrement for every hop. While sending itself, it is sent with 1. So when it reaches the immediate router, the TTL will become 0, meaning the lifetime of the packet is over. The packet don't have any more life. It is for security they have did this. You are forming eBGP neighbor. Forming eBGP neighbor, you cannot simply form with someone who is too far away. You want to see and confirm that I am forming neighbor with the directly connected. That is the kind of security that we get through eBGP. For the security sake, they have designed like this. But for IBGP, you don't have that limitation. IBGP can be any remote neighbor. You saw that, right? Within an organization, IBGP can be any router. Need not to be directly connected. But why for eBGP need to be directly connected? Security. You can see and confirm. In the routing table, you can see directly connected. And when you send the packet won't go more than one hop. So it's a security. So if attacker is somewhere here, it won't go form neighbor with the attacker, because the packet expires right here itself. After reaching router 2, the packet expires. It's a security. Alright, now coming back to the story. There's a command called neighbor address EBGP multi-hop, where you can increment the TTL value to 2 or 3. I said by default the TTL value, outgoing TTL value is 1. Why should I increment the TTL value? Just now I learned that it is a security to have, it is good to have one hop. Just now we learned it is good to have TTL of one hop. Then now why we are learning here to increase the TTL value. This teaches how to increase the TTL value. The reason is, if you are forming neighbor using loopback, you need to increase the TTL value. What is the connection? What is the connection? Because I'm using the loopback, see, I'm going to say, instead of 10.1.1, I'm going to say neighbor as 2.2.2.2. When I say 2.2.2.2, is 2.2.2.2 directly connected? No. 2.2.2.2 is not directly connected. So you will write a static route or something saying 2.2.2.2 go to 10.1.1.2. This is the static route that we will write. So when I write the static route, you see, I'm going to write the static route. If I want to form neighbor, I must write a static route. If I want to form neighbor using loopback, I must write the static route, IP route 2.2.2.2 255.255.255, send it to 10.1.1.2. I need to write a static route. See, is static route shown directly connected? No, it says via. It is not directly connected. When it is not directly connected, for that network, since 2.2, because 2.2.2.2 is not directly connected, for that destination TTL cannot be 1. Only for the directly connected TTL can be given 1. For the network which is behind router 2, which is not shown as directly connected in router 1's routing table, TTL cannot be 1. But what is the default? TTL is 1. So the packet will not even go out. Router 1 will say, I got a route, no doubt in it, but BGP rules will not allow me to send a packet. Why the rule will not allow? Rule says it needs to be directly connected. Only then I can put TTL 1 here. But it is not directly connected. This destination, though I have route, it is not shown as directly connected here. So I cannot proceed any further. This packet won't even go out of R1. R1 will not send even a single packet outside. If you sniff packet and see using Wireshark, you will see nothing coming out of these routers. I'll show you some other day because some other video extraction and all going on. If I start that Wireshark, it will be choking our CPU. So what I'm coming to say is the packet will not go out now, because the destination to which the BGP negotiation need to happen is not seen as directly connected in the routing table. Now if you want this packet to go out, you need to change the rule. What is the rule? You need to set something greater than 1. The TTL count as greater than 1. Meaning you are breaking that security policy. You are breaking that security. TTL 1 is a good security. But in our case, if TTL is 1, the destination need to be directly connected, which is not true because we are using loopback interface address. Loopback interface address, how it will be showing as directly connected in the routing table? Not possible. So we break the rule by putting TTL2. See, that's what happens here. What you are saying is this destination need not to be directly connected. In the routing table, it need not to be seen as directly connected. So when you put 2, when we put 2, we break the rule. So we are telling BGP it's okay. We are telling BGP it's okay even if it is not directly connected, even though it is saying via, it's okay. You can send the BGP packet. So now it puts 2 and it will send the BGP packet here. Now what is the neighbor address you configured here? 1.1.1.2. But the incoming packet is not matching with the neighbor statement. So what should I do? Tell me. If I want to match the incoming source and the neighbor list, what should I do? What command? Come again?
Need to change the neighbor statement, sir.
You'll change the neighbor statement itself. No. We want to form neighbor using loopback. That we cannot change.
Okay,
if I want to change the source,
we need to use the one, first of all, the status of
update source.
eligibility.
Update source, loopback 0 command, right?
Yes.
It really makes me sad when when you don't answer immediately. Okay, anyway. See, we have focused on this so far, and I asked question about this because we covered this yesterday. You don't go and change the neighbor address. Neighbor address should be 22222 because we want to form neighbor using loopback. But to match this 22222, when I source the packet with my loopback 0, router A will send with source address 2222, which will match here. Yeah. So in IBGP case, we don't need this statement. We need only these two. But in eBGP, we need this as well as this, as well as a static route, so that A will know where is that 11111 and B will know where is the 22222 that we have defined as a neighbor. So let me go back to our topology. In our topology, even though I don't have two links, I just want to show you how to form neighbor using loopback. So I go to router 2 BGP 20 and I say neighbor 2.2.2.2 remote AS is 10.
So it's neighbor 1.1.1.
Yeah, neighbor 1.1.1.1.
Yeah, 1.
Yeah. So I say neighbor 1.1.1.1 remote access 10, and I say neighbor 1.1.1.1 EBGP multi-hop 2. The reason why I say this is only then it will try to send the packet out even though this one network is not directly connected. First of all, do we have that one network in the routing table? Show IP route. No. Let's write IP route next stop. Yeah, now we have the route. So show IP, show run, listen carefully, show run. We can see in the BGP I need to remove this old statement. Okay, this is old statement, the physical interface statement. Let me remove this first. Oh my god, what is this kidding me a lot?
It's 26.
Yeah, I removed it now. Show run pipe section BGP. So we have got this. We even have a route. I wrote a static route. You saw me show IP route. We even have a route to reach, but they won't form neighbor because the source of the packet is going to be the exit interface address, not 2.2.2.2. Let's finish router 1, router 2 configuration. Router 2 has got this configuration. Router 1, show run section BGP. What do we have in router 1? Nothing. Let's configure BGP. Router BGP 10. Neighbor is 2.2.2.2. Remote access 20. Neighbor is 2.2.2.2. EBGP multi-hop 2. So even though we have given this, what we have not given is the yesterday syllabus. Update source loopback 0 command is not given. We are not given that command update source loopback 0. This command, second command. As a result, they will not form neighbor. Even though there is root, you see, you can ping 2.2.2.2. Though you are able to reach between these loopbacks, between these two loopbacks, neighbor is going to get established. Though you can reach, the neighbor is not coming. Show BGP summary. The neighbor is not coming. Why? Active is not good, Active is searching for the neighbor actively. Still not established. It's actively working very hard to establish. So the neighbor has never come up. If I debug and show you, you will understand why. Debug IP BGP all Right, I said because BGP has, okay, now this is enough for us. Look at this. From where the packet is coming, 10.1.1.2 to the destination 1.1.1.1.1. If packet comes from here, will this source address match with the neighbor statement in this router?
No.
Neighbor statement says the source address should be 22222. But here it says the source address is 10.1.1.2. The exit interface of router 2 is what used here to send the packet. Likewise on router 2, debug IP packet detail. In router 2 also, if you see, the packet will be coming from 10.1.1.1, not from 1.1.1.1. No. Mute your mic, please. Okay, you see the packet is coming from 10.1.1.1. Kindly mute your mic. Thank you. The packet should come from 1.1.1.1, but it is coming from 10.1.1.1. How do you change the source address? By using this command, update source. Router BGP 20 neighbor 1.1.1.1 update source. Use the loopback interface address to solve the problem. See, from that side the neighborship has come. It's recommended to do it on either side. Because of TCP, if one side is configured, it will come up, but don't get convinced with that. You have to do it on both sides. Update source, loopback 0. Alright. Now you're going to see neighbor show IP BGP summary. You can see now the BGP is up. It's not saying neighbor active. It says BGP is up for last 24 seconds. So far no prefixes learned, because we have not advertised any prefixes. If you want, you can advertise now. Let's go to router 1. Okay, router 1, I say interface loopback. A new interface I'm adding with the address called 11.11.11.11. This I'll advertise in BGP, router BGP 10, network 11.11.11.11, mask 255.255. Now, if you go to router 2, you will see 1 show IP BGP. You are seeing this 1 instead of 0. The reason is show IP BGP. You got this network you learned this 11 network from router 1 from the autonomous system 10. We are in which autonomous system? Autonomous system 20. We have learned it from autonomous system 10. Now check the routing table, show IP route. You can see via BGP whose administrative distance is 20. I said for eBGP administrative distance is 20. We have learned this 11. So you can ping now from here 11.11.11.11. Show IP route 11.11.11.11. Same routing table I'm showing like this. It says that this route is learned via BGP from via BGP 20. That is what the local autonomous system. Administrative distance is 20 because it's eBGP, and the update was coming from eBGP neighbor whose address is 1.1.1. That's how you form neighbor, no? From 1.1.1.1. AS hop. How many AS hops? 1 hop. How many AS? 1 hop. And what is that AS? 10. 10 is the AS number. That's the tag value. We can also type this command and see show IP BGP. You see 11, 11, 11, 11. If you want to see in detail, you can say this. And it says that 11, 11, 11, 11 slash 32. One path available, one best path. And then it is advertised from the remote autonomous system 10, and it is given by the eBGP neighbor 11111. It is BGP's own protocol. That's why it is shown as IGP. It's not IGP routing protocol. It's not OSPF or AIGF. It says originated from BGP by using network command, not redistributed. Local preference, metric, MED, all those things we will be learning later. These are all attributes. We'll talk about this later. So, show IP BGP command will show you this thing. Show IP BGP advertised.
The neighbor.
Show IP BGP neighbor. Why you say neighbor?
Neighbor then advanced routes, right, sir?
Okay. Yeah, that's right. Neighbor received routes. I want to see what I receive from neighbor 11111, not 2222. I meant router 2. Inbound software. Okay, sorry. In this version of operating system, inbound receive routes are not allowed.
We have to enable that.
We'll just talk the default now. Now on router 1, show IP BGP neighbor 2.2.2.2. Advertised route. Neighbor. Advertised route. Now you can see that router 2 to router 2, this router 1 is advertising this network. Fine. So these are some verification commands. So what we learned today is when you have eBGP, forming neighbor, eBGP neighbor between loopback is not a usual one. It's unusual. It's unusual. Very rarely we'll have these redundant paths between eBGP neighbor. Only if you have redundant paths, it is good to have loopback to loopback neighborship. If you are using loopback to loopback neighborship, then you need to make sure that you increment the eBGP multi-hop. Using eBGP multi-hop, you increment the TTL value, because the default TTL value is 1. If the default TTL value is 1, it will look for directly connected in the routing table, which is not going to be true when we write a static route to reach the loopbacks. Whether you write static route or run some other routing protocol, it is not going to show directly connected. So to break that limitation, we put eBGP multi-hop 2 so that the route to reach the neighbor need not to be directly connected. Next is to change the source address, we need to say update source loopback 0, otherwise the source address won't match with the neighbor statement, which we learned in the previous class. Right, about the next hop behavior, please understand, I showed you this one just now in the output. I am going to repeat that again. Listen. Show IP route R1, R2. If you see, Show IP BGP. Listen. Who is the actual next hop? In router 2, what is the actual address? 10.1.1. Sorry, in router 1. This is coming from router 1. I'm checking in router 2. What should be the actual next hop? 10.1.1.1. Why it is not showing 10.1.1.1? It will not show 10.1.1.1 because the address with which you form neighbor will be the next hop. How router 2 knows autonomous system 10? How router 2, come on, show IPv6 someone. How router 2 knows autonomous system 10? It knows as 1.1.1.1. That is what going to be explained here in the neighbor statement. BGP is an AS by AS routing protocol. It is not router by router routing protocol. So, the next hop does not mean the next hop router's address. It means the address to reach the next autonomous system. We reach the next autonomous system using loopback. So the loopback address will be seen as the next hop. It won't be real physical interface address or the next immediate router's address. Whatever the address that you use to identify the neighbor. I don't know. This cock is also trying to teach us networking, competing with me. Bear with that sound. My neighbor intentionally put all this hen next to my window only. He knows I teach from here. Such a good neighbor I have. Fine. Now, BGP is an autonomous system by autonomous system routing protocol. In BGP, the next hop does not mean the next router or next router's address. It means the IP address to reach the next autonomous system. For eBGP, the default next hop is the IP address of the neighbor router that sends the update. How do you send and receive update? If you are sending and receiving update using loopback interface address, that is what going to be your default next hop address. For iBGP, the BGP protocol states that the next hop advertised by eBGP should be carried. Okay, we'll talk about this rule in tomorrow's class. It is something which we need to really focus a lot. Right? This we will see tomorrow. Hope you understand these points and the previous scenario. Do this and see. If you want, you can take a screenshot. Do this similar lab and see. That will give you a learning experience. We'll meet tomorrow. We'll continue this tomorrow. Any question on what we have covered today?
Sir, the last point, what you mentioned, can you just go back to that bullet point? The last point, the third one, for eBGP.
For eBGP, the default next hop is the IP address of the neighbor router that sends the update.
Okay, to whom I build up the network neighborship.
Yeah. See here.
Okay.
What is the neighbor address that sends the update? When you say update source loopback 0, the source address will become what? 1.1.1.1.
Yeah.
That is what your next hop. For router 2, that will be the next hop, correct? It is not 10.1.1.1. I showed you in the output, no? Your next hop did not show 10.1.1.1. Instead, your next hop was showing 1.1.1.1 because that is what sending you the update. Correct?
Yes, sir. Got it.
Any other question?
So one more question I have. eBGP multi-hop 2. We mentioned that this is for, as you said, it goes to more than one for in case of eBGP. But in case of iBGP, it can reach up to 255.
Yeah, you no need to set this command. It is by default 255. If it finds neighbor in the 5th hop, it's okay. If it is finding the neighbor in the 100th hop also, it can form neighbor. There is no limit like within 100 hop, within 200 hop. Even if neighbor is 255th hop, this can form neighbor.
while we are with the IBGP. Okay.
All right, we stop here. We'll continue this.